Hi, my name is Raam. Welcome to this video where I describe the work my co-authors and I have done for our WACV paper, Can You Even Tell Left from Right? The main points of our study are that we proposed a synthetic data set for visual question answering. This data set is meant to evaluate compositional generalization in VQA models. We believe that this is important since several existing data sets are not really suitable for compositional evaluation. In the context of our paper, what do we mean by compositionality? We define this term to be the ability of a model to identify concepts across scene compositions. So, in the example that we can see, a compositional model would identify a seated cat across both the images. We have another example here where relationships are studied. Here, a compositional model would detect the relation human eating a snack across various scene compositions. In the context of VQA, what is a good data set? In addition to its scenes being complex, a good data set should also ensure that the train and test data are separated compositionally. Also, this compositional separation condition should be sufficiently challenging so that models can be evaluated better. Consider the examples here. In both of these images, we have a bunch of boys playing football in very similar scene composition spaces. If such similarities occurred across the train and test data, we would have some issues in learning to evaluate if a model actually can generalize well in predicting answers about concepts in scenes. We developed two measures to detect such overlap, focusing on commonly co-occurring objects as well as relationships between objects. Ideally, for evaluating compositionality, there should be no overlap, while also maintaining good complexity in the scenes. This table summarizes these scores for compositional separation for several data sets, including our own proposed data set, UOUC. Please just focus on the first and third rows. The second and fourth are auxiliary scores and will not be considered for the remainder of this talk. We see that our data set has scores of 0, indicating no overlap. Indeed, we designed UOUC such that no pairs of objects occur in both the train and test data set. This ensures a complex and strong compositional separation condition for our train and test data set. UOUC is also complex in that it has a large set of diverse object classes, making it quite close to real life scenes, but with the added benefit of a compositional separation. Here are some example objects of our data set. Note the diversity and complexity of the object classes. This is quite the contrast when we consider a popular synthetic data set, Clever, where the object classes consist of simple geometric shapes. Here are some example scenes for our data set, UOUC. We thank Miguel Zavala for allowing access to his 3D models and his permission to use them for our data set. In UOUC, we have 4 types of questions. The first of these are what we call SRB, or spatial reasoning based questions, where we test compositional reasoning for spatial relationships as seen in the examples. The second type of questions are SR, or simple reasoning questions, where we test simple reasoning as shown in the examples. The third type of question are what we call P-type or perception type questions, where we query if an object with a specified description is present in an image. The fourth type of question are MB type of questions, where we test for a variety of text-based tasks as seen in the examples. We tested a number of models on UOUC. As seen in the table, these perform reasonably well on other datasets such as VQA, Clever and GQA. On UOUC, however, we see that all the models perform randomly on the SRB binary questions. This indicates that the models do not understand the notion of spatial relationships, at least seen in the context of compositional generalization. We also see that the other questions are relatively easier or relatively simpler for the best models that we have considered, with memory and perception also being quite doable. However, as the results show, compositional generalization is quite hard and more research needs to be conducted to improve in this. As future work to improve the current state of the art in research, we need compositional models that in the sense of compositional generalization that we have described. We could also study text-based reasoning in terms of compositionality to evaluate models on predicting unseen text pairs for concepts. We also would like to study larger models in similar ways to determine their compositional generalization better. In conclusion, we would like to thank you, the viewer, for listening to this talk. Thank you very much.